Okay, so we'll talk a bit now about how to collect and interact with the results of a finished simulation. So we're here at a page for one of the simulations we kicked off in this tutorial. And as I described earlier, as you scan down this page, you'll see that DandeLiion provides kind of in-browser plot of some of the basic simulation output. Now, if you'd like to interrogate your simulation in a bit more detail, what you can do is use the link provided at the bottom of the page to download the raw output in the form of a zip archive. So if I download this archive and open it, we'll see that it contains a bunch of .dat files. So these contain the raw data for the different state variables in our simulation. And I think an easy one to understand initially would be, for example, the voltage data. So I'm going to go and open that DAT file. You'll see it's just a plain text format. There are 3 columns in this case, one for time, one for capacity, and one for voltage. And you can import this into most plotting software. So certainly MATLAB, things like that will be able to read in these text files. Another alternative which might be attractive to people would be to use some kind of spreadsheet software. And what you can do with that is select the data, copy it, go to your favorite spreadsheet application and paste that data in. And there it is. And then we can produce our plots using the spreadsheet software. So I can, for example, select the time data and the voltage data, and then go and ask Calc or perhaps Excel to plot this data, and perhaps voltage versus time seems sensible that I would want a line plot or a scatter plot for that. So there's a basic plot of the voltage versus time. Okay, another type of state variable that you might like to interact with would be one that's more complicated than the voltage, in the sense that it depends not only on the time into the simulation, but perhaps it's a variable that depends on space and time. So a good example of that, I think, would be something like the concentration in the liquid. So this is the ionic concentration in the electrolyte. If I take this .dat file and open it up, you can see that rather than just being columns of data, there's now rows and columns of data. And in the text file, you can see that the different rows correspond to different values of macroscopic position X listed here, whereas the columns correspond to different times. So again, the formatting is probably easier to read to the human eye if we copy this into spreadsheet software. Like so. We can see these are values of the concentration, as I say, at different values of X, corresponding to the different rows, and different values of time corresponding to the different columns. So if I wanted, for example, a snapshot of the concentration of ions in the electrolyte at, let's say, 3000 seconds, what I could do would be to highlight this column of data and also this column of data, and then ask the software to produce a plot for me. So I'll do, again, a line plot, and I get something like that. So that's the, as I say, the concentration in the electrolyte at 3000 seconds as a function of spatial position through the cell. Okay, the final type of variable that you might want to interact with is one that depends not only on time, not only on macroscopic position, but also on microscopic position, so radial position within an electrode particle. So a good example of that would be the concentration inside a cathode particle. And you can see that DandeLiion returns several relevant DAT files. So the way to understand these file names are that this one here, for example, is the concentration in the solid in the cathode at a position X, which is halfway through the cathode. So XREL here should be understood as normalized position, or if you prefer to think this way, non-dimensional position. So this DAT file contains the data for the concentration in the cathode particle midway through the cathode. This one contains the data for the concentration in the cathode particle near the separator, and this one for the cathode particle near the current collector. And you'll see that if you open any one of these, you've got a familiar matrix. So again, the columns correspond to different times, and there's a reminder in the top left corner here which macroscopic position you're talking about. So this one is halfway through the cathode, and then the different rows of data correspond to different radial positions within that cathode particle. And once again, you could manipulate this data using your favorite plotting software. Okay, so the final thing to say is what you should do if you would like to tweak one of the settings in your simulation and resubmit to the queue. So let's imagine that there's a hiccup in the results and they're not quite as we expected, or perhaps we'd like to investigate a different discharge rate. Well, to save you the trouble of filling in another simulation form from Fresh, what you'll see is that there is this button in red at the bottom, and if you press that button, you'll be returned to the simulation form, and this one will be automatically populated with whatever information you gave it on the previous run of the simulator. So if you wanted to tweak just one or two settings, you could do that here. So for example, perhaps you tweak the discharge current, and then resubmission of your job follows in exactly the same way as we've talked about previously. You come down here, you check the terms of service are agreed to, and then you submit your simulation, and once again it will rejoin the queue for processing. Okay, so thank you for listening.